Okay, this is going to be a discussion of L14-Cost worksheet. Before you start the worksheet, please be sure to have completed the preparation for L14-Cost. We've got some reading and man cue, notes, a series of videos to watch, the summary questions that are particularly important are the ones dealing with cost, fixed cost, variable cost, total cost, the three average cost, and marginal cost. Also, if you scroll down, you'll find the check your understanding questions. Of particular interest are the L14-Cost screencast 1. There's a table that looks a lot like the one we're getting ready to do. Walked through it once with you, but we're going to do it again this time. After you've done the preparation, work on the worksheet and then click on the key, which is buried at the bottom of that worksheet. Here's the key. The first question asks, what is fixed cost in all of the column in the entire column? You were told fixed cost was 1,000 when quantity was 20. Well, fixed cost is constant. It's the easiest column to figure out. If it's 1,000 in one row, it's 1,000 in all the rows. So we just put 1,000 in each cell in the column for fixed cost. The next question says, what's the fill in the row for when quantity is equal to 0? Well, we know fixed cost is 1,000. We also know that variable cost is 0 when quantity is 0. Variable costs are costs that can be eliminated. If the firm is not going to produce anything, it will eliminate all of the costs it can and therefore cut variable cost to 0. Total cost is the sum of the two. 1,000 plus 0 is 1,000, and we're done for that row. We're told that variable cost was 100 on when quantity was 10. Total cost is again the sum of fixed and variable cost, gives us 110. The averages are simply the totals in the first three rows divided by the quantity. 1,000 divided by 10 is 100. 100 divided by 10 is 10. And 1,100 divided by 10 is 110. Notice the sum of the average fixed and average variable cost equals average total cost. In fact, I've got a little formula stuck up here at the top of this in the headings for each column to show some of the relationships that we're going to use throughout this exercise. For example, fixed cost is total cost minus variable cost. It's also average fixed cost times Q. I've got those same relationships posted in the key. Please look at the transcript to look at that a little more closely. All right, the row in quantity is 20. We knew fixed cost was 1,000. We know total cost is 1,160. Variable cost is the difference of those two. The averages are just these three totals divided by 20, and marginal cost is equal to 6. Let's talk a little bit about marginal cost. Marginal cost, the first marginal cost was a value of 10. We found that by taking the difference in total cost and dividing it by the difference in quantity. Total cost rose by 100, output rose by 10. 100 divided by 10 gives me marginal cost of 10. That tells me that as output rises from 0 to 10, each extra unit of output makes the cost of the firm rise by $10. When quantity goes from 10 to 20, total cost rises by 60. Quantity rises by 10. 60 divided by 10 gives me 6. That tells me when quantity goes from 10 to 20 that each extra unit of output costs the firm an additional $6. Let's look at the row when quantity is 30. Here we do the average variable cost. If we multiply average variable times output, we can find our average variable times output. We'll find our variable cost, 7.5 times 30 is 225. If we add 1,000 plus 225, we get the total cost. We divide by 30, we get the averages. The marginal cost is the change in total cost divided by the change in output. The row in quantity is 40. We know average total cost is 35. If we multiply average total cost times output, we'll find that the total cost is 1,400. We know fixed cost is 1,000. The difference is 400. Divide by 40, we'll get those two numbers. Marginal cost is the change in total cost divided by change in output, which equals 17.5. For the row with quantity is 50, we know that marginal cost is 40. That tells us that that tells us when quantity goes from 40 to 50, each extra unit of output costs us 40 extra dollars. We've got 10 extra units of output. If each extra unit of output costs us $40 extra, that means that when quantity goes from 40 to 50, total cost is going to rise by a total of 40 times 10, or 400. Total cost is going to get started at 1,400. If it rises by 400, it means the new total cost must be 1,800. So we take 40 times 10. That's the difference in total cost, and I use that to compute the new value for total cost when quantity is 50. Divide by 50 for all these numbers, we'll get the averages. And the last row when quantity is 60 is basically a repeat of the row when quantity was 10. We can plot these on the graph. I asked you to plot the average variable cost curve. So we know from our chart that when quantity is 10, average variable cost is also 10. So here's 10 on the horizontal axis. There's 10 on the vertical axis. If we get those two things together, we'll be right there at that point. That point shows me when quantity is 10, average variable cost is 10. Notice we measure quantity on the horizontal axis, and we measure dollars on the vertical axis. When quantity goes to 20, average variable cost falls to 8. So this point's a little lower than 10. That height there is $8. There's 8. When quantity goes to 30, it gets a little bit lower. There's 7.5. Quantity 30, 7.5. When we get to quantity of 40, total cost, average variable cost starts to rise. There's 40 and 10. And then we get 50 and a little higher, 50 and 16. And finally, we get 60 and 21.67. So the average variable cost curve is a U-shaped curve. Hits its minimum somewhere around 20, 25 or something like that. The next curve I want you to plot, or one curve we talked about, is plotting the average total cost. And I actually do that as long as quantity was greater than or equal to 30. So here quantity is 30. When quantity is 30, the average total cost equaled 40.83. So here's a height of 40.83. I go across to a quantity of 30. That point there tells me when quantity is 30, average total cost is 40.83. When quantity rises to 40, the average total cost falls to 35. There's 35. When quantity goes to 50, it's a little bit higher. There's 36. And when quantity is 60, it goes up to 38.33. Again, the average total cost is a U-shaped curve. It's its minimum somewhere around 45 or something like that. Marginal cost. I plotted marginal cost halfway between the quantities we use to compute the marginal cost. So here's a quantity of 5. We went from 0 to 10 and found the marginal cost was equal to $10. So I'll plot that $10 marginal cost at a quantity of 5. The next quantity we jump to is 15. When the quantity went from 10 to 20, marginal cost is equal to 6. So there's my height of 6. Then we go to 25. The marginal cost when quantity went from 20 to 30 was 6.5. There's a height of 6.5. 35. The marginal cost is 17.5. 45, the marginal cost went to 40, and 55, the marginal cost went up to 50. And if I connect those together in sort of a smooth curve, I'll get another U-shaped curve with a minimum somewhere around 20. Now let's drag this guy down a little bit. Oh, I don't want to do that. We'll get you. There we go. Now let's grab it on down here and talk about the questions with the graph in our face. So the first question I asked is, what happens to average total cost when output increases from 30 to 40? Well, it decreases from 40.83 to 35. We can see that. Here's a quantity of 30. There's a quantity of 40. The average total cost is going down. Now, what's the marginal cost over that range? The marginal cost was equal to 7.5. Here's the marginal cost. Here's the marginal cost over that range. Oh, that's actually 17.5. That's my trouble. It equals 17.5. Let's change it. Well, 17.5, you can see, is below either of those two average costs. Whenever the marginal cost is below the average, it pulls the average down. If marginal cost is below the average total cost curve, the average total cost curve has a negative slope. When quantity goes from 40 to 50, the marginal cost is 40. So here's a marginal cost of 40. The average total cost goes from 35 to 36 in that range. It goes up a little bit, not much of it, but it's an increase. Whenever marginal cost is above the average total cost, the average total cost curve has a positive slope. You put these things together, you're going to figure out that when the marginal cost intersects the average total cost, the average total cost will be at its minimum. So I've tried to, the green curve, the marginal cost curve, passes through the orange average total cost curve, where the average total cost curve is at its lowest point. That's got to be the case. Whenever the green curve is below the orange curve is going down. When the green curve is above the orange curve, the green curve is going up. The green curve will be flat only where the marginal cost equals the average total cost. Marginal cost and average variable cost also have that same relationship. When the green curve is below the red curve is a negative slope. When the green curve is above the red curve has a positive slope. The green curve intersects the red curve at the minimum point on the red curve. There you go. Till next time, we'll see you.